In this lesson, we're going to talk about using the disk method to find the volume of a three-dimensional object when we revolve a specific region around an axis or a line that is not an axis. So we could revolve around any horizontal line or vertical line easily using this technique. All that we have to do is determine our new radius, and our radius can simply be calculated by finding the upper curve and subtracting the lower curve. So we're still going to have that formula of pi r squared, but our radius is going to be the upper curve minus the lower curve. So here we're asked to find the volume of a solid formed by rotating the region bounded by f of x equals 2 minus x squared and g of x equals 1 about the line y equals 1. So if I draw a picture of this, I have an x-axis, I have a y-axis, I have the curve 2 minus x squared, which everyone should realize this is a parabola that points down, shifted up 2 units. So up 2 units, it points down, and we're not going to hit the x-axis actually at an integer value. It's going to hit actually the square root of 2 and negative the square root of 2. So this is my f of x, and then I'm going to have g of x equals 1. So that's like the horizontal line y equals 1. And to calculate this, we need to realize that we're working with this section right in here, so I'm going to make a perpendicular slice to my axis of revolution. G of x equals 1. And I could show what section I'm working with by using my highlighter. So I'm working right in here. So all we're going to do is we're going to calculate a new r. That's really the only difference, is calculating a new r value. So r of x here will be equal to the upper curve, f of x, minus the lower curve, g of x. So f of x is that 2 minus x squared, g of x is 1, so when I subtract these, I'm going to have 1 minus x squared. When I calculate this volume, I'm going to be using that formula, pi times the integral from a to b of r of x squared dx. So I still need to know where they intersect, so I need to know where this intersects to the left and to the right. So if I was to set these equal to each other, 2 minus x squared is equal to 1. So if I was to move x squared over, I could say x squared equals 1. So I have plus or minus 1 equals x. So I will have my volume equal to pi times the integral from negative 1 to 1 of the radius, which we figured out was 1 minus x squared, squared dx. So again, I could take the time to work that out if I wanted to, but for time's sake, to shorten up this video, I'll just put it in the calculator. So in my calculator, I can do math 9. I'm going to go from negative 1 to 1. I'm going to have the quantity 1 minus x squared squared dx. And so I get that 1.06 repeating, 1.06 repeating times pi. If I wanted to write that as a decimal rounded to 3 places, I could say times pi and come up with 3.315. Sorry, it might be 3.351. I misspoke. So let's try another one like this. Find the volume of the solid formed by rotating the region bounded by h of x and g of x about the line y equals negative 7. X, y, put in the horizontal line, g of x equals -7. That's y equals -7. I know that the curve, the parabola h of x, has a y-intercept of -12, so I'm obviously going to be beneath this g of x equals -7, but I don't know exactly where it heads g of x equals -7 unless I set them equal to each other. So I'm going to set x squared plus 4x minus 12 equal to -7. If I add 7 to both sides, I get x squared plus 4x minus 5 equals 0, which is easily factorable into x plus 5, x minus 1. So x equals -5 or x equals 1. What that means is that these are going to intersect at the x values -5 and 1. So if I was to the right, just 1, I'd hit right here. If I was to the left, to -5. All the way over to -5, maybe over here. I'm going to get that intersection. So what I'm going to see is that I'm going to have a parabola that goes about like this. And it really doesn't matter to me where it hits the x-axis. I could determine it, right? I could solve and set x squared plus 4x minus 12 equal to 0, but I don't really care about those intersections. I care about these intersections, where x is equal to -5 and where x is equal to 1. So I'm going to take this region right here that's trapped between g of x and f of x, this region right here, that's trapped between g of x and f of x, and rotate it about the line y equals -7. So I'm really just rotating it about g of x. So I'm going to draw that perpendicular slice in there, because with the perpendicular slice, it's going to help me in the future when we start talking about shell method. So volume, right? Volume is equal to pi r squared, so pi times integral from a to b of r of x quantity squared dx. So r of x, the radius, can be written either way. We can do the upper curve minus the lower curve, or the lower curve minus the upper curve, because I'm going to square it anyways, so it doesn't matter. But let's say we go upper curve minus, just for the fun of it. So we'll say -7 minus quantity x squared plus 4x minus 1. So if I combine like terms right here, r of x is equal to -x squared minus 4x, and we have minus negative, so that's plus 5. So this is going to be equal to pi times the integral, and we have to go from intersection to intersection. So from -5 to 1 of -x squared minus 4x plus 5 quantity squared dx. And again, I can just throw that whole thing in the calculator. So if I throw that in the calculator, I can say second pi, I can say math 9, I'm going to go from -5 to 1, and I'm going to have the quantity, so I need that extra parenthesis in there, -x squared minus 4x plus 5, close the parenthesis, squared. And I'll throw a dx in there. I already have the d, I just need to add the x. Make sure all my signs look correct, and that gives me an answer of 814.301. So let's try one more where we do everything in terms of y's and take that horizontal slice. Here we're going to find the volume of the solid form by rotating the region bounded by f of y equals the square root of the sine of y plus 2, y equals 0, y equals pi, and g of y equals 2, about the line x equals 2. So let's draw this to the best of our ability. We need to use the line y equals 0. So y equals 0 is that horizontal line, it's called the x-axis. So I'll just label the x-axis as y equals 0. I need the horizontal line y equals pi. So we'll go up here to pi. And it'd probably be useful for me to show pi over 2. So I'm going to take the square root of the sine of y plus 2. So typically this would shift us up 2, but since it's a y value, it's going to shift us to the right 2. So if I had 0 in as a y value, I'd have the sine is 0, the square root of 0 is 0. So I'm just going to be shifted to the right 2. If I had pi over 2, sine of pi over 2 is 1, plus 2 is 3, so I need to get up to 3. And then if I was to go to pi, sine of pi is 0, so I'm back to 2. So I would have something that looks like this, and if we were to continue graphing, it would look like sine curve, but vertically. But we only really need this section because we have this vertical line, g of y equals 2, which is like x equals 2 is what we should be thinking. So I'm going to have a vertical line right here, x equals 2, and I have my horizontal line right here, y equals pi. I have my horizontal line right here, y equals 0, which I already had labeled. So I'm going to be finding the volume, assuming that this region right here, remember this right here is f of y, this right here, the straight line, is g of y. We find the volume of that region trapped right between f of y and g of y, between 0 and pi. So my volume is still equal to pi r squared, but we're going to be writing everything in terms of y here. So we're going to have pi times the integral from c to d of r of y squared dy. So r of y is the upper curve minus the lower curve, so upper is further to the right, so we're going to have f of y minus the lower curve, g of y. So f of y is the square root of sine y plus 2 minus g of y is 2. So this is equal to the square root of the sine of y. So when I substitute in, I'm going to have pi times the integral. We have to go low to high. So when we go low to high, we're going to go from 0 to pi. R of y is the square root of the sine of y, and I'm going to have that quantity squared dy. So when I square the radical goes away. So I have pi times the integral from 0 to pi of sine y dy. When I integrate sine, I get negative cosine y, and I'm going to evaluate that from pi to 0. So I'll have pi times negative cosine of pi. Cosine of pi is negative 1, so negative 1 minus negative cosine of 0 is 1. So with these double negatives, I actually have plus positive and plus positive, so I have 2 pi. So this is how we find the volume of a region, or the volume of a three-dimensional object, based on revolving a specific region, an area, around a line other than an axis.